Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super. Today we're going to be focusing on an incident that happened in Australia East, which is one of our data centers in Sydney. It started on the 30th of August, which was a Wednesday evening for our folks in Australia. But there were three really unique things for me that characterized this incident. The first one was that it impacted one zone, and I'm curious to understand the impact of what happens when one zone goes down. The other piece was that it did impact some of our core services, which had a very long tail on recovery. And the third one is that for one of our services, for AKS, Azure Kubernetes Service, this impacted multiple regions slightly. So I'm really interested to learn a little bit more today about this.
Great, thank you. And to help us learn all of those, I'd like to introduce today's panel. So joining us remotely, we have Michael Hughes, our Vice President overseeing all of our APAC data centers. Elvin Howman-Haig, our General Manager of APAC Data Center Operations. Joining me live here in Redmond, we have Tom Jolly, Vice President of Azure Storage. Asad Khan, we're Vice President of Azure SQL Database, and Kirill Davrulik, GM, our General Manager of Cosmos Database. And then finally, joining us online a little late for the East Coast, we have Chi Ki, our Corporate Vice President of Azure Kubernetes Service. So thank you all for being here.
Super duper. Of course, we want to start with the trigger of this issue, which was a power cooling event in one of our data centers. Michael, I want to ask you, I'm sure voltage dips and power sags are not uncommon in the utility world. What's supposed to happen during a power event?
Okay, good morning, everybody. So first of all, I just want to apologize to all of our customers who were impacted by the event. And let me just give a brief explanation of our Australia Southeast region. It's 3 availability zones. And what happened is this was 2 data halls in 1 data center in one of the availability zones. So about 3% of the total capacity that we have available supporting Sydney. Now, what's supposed to happen is the data centers are designed to run off the grid indefinitely if needed. They're always backed up by diesel generators, so they always have a power source, right? So in this case, this issue was a thermal issue, right, caused by a series of chiller failures, right? Now there's a couple of questions which are useful just to get into, like why do we use chillers, for instance, in Sydney? So let me just talk for a second about how we cool data centers. For instance, in the Northern Hemisphere, in North America or in Northern Europe, we'll use things like free air cooling because the overall temperature never gets that hot. But in countries, especially in Southeast Asia or anywhere where we're likely to experience high temperatures or we might have a lack of water, there we'll use chillers, right? Now, chillers are, just for context too, this data center has been running for 5 years. It's a very large campus with, I think, 40 to 50 megawatts live in it, and it's never experienced an outage before, right? And similarly, just to kind of hopefully give you some confidence, we ran for an entire year in the Asia Pacific region across 77 data centers where we didn't even experience a minute's data center infrastructure outage. So I just want to reassure people that we have a really large team of experts supporting your infrastructure across the region, right? Now, so where did this one go wrong, right? Essentially, we had 3 sags. So just to put that into context, over the last 2 years, we've had a total of 48 sags impacting this site. The first 45 of them, the systems rode smooth, there was absolutely no issue. And then we had an electrical storm where we had 3 sags, all impacting the site within a very short period of time. Now, the sag was long, it was over 100 milliseconds. And in some respects, anything less than a second is backed up. So for instance, our IT equipment is backed up by UPS. It can ride through that. But because our HVAC equipment is very large electrical equipment, that's backed up by generator. And typically anything where the outage is over a second, the generators are going to kick in and these are going to be supported. Because this was less than a second, the systems should have been able to ride through. So all of the chillers are supposed to auto restart. Now, in this case, the 13 of them required a manual intervention. So I can talk. Maybe you want to ask me another question. Do you want to deep dive into some of the issues that caused those problems?
Yeah, this is sounding great already. Thank you for getting the ball rolling, Michael. I'll put in a slight correction here for both Sammy and for you, because Sammy talked about our Sydney data center in the introduction. We know that he meant our Australia East region based in Sydney, which is made up of multiple data centers. And Michael, just a slip of the tongue there, I know you mentioned Southeast, where everything we're talking about is Australia East until you get to Chi and the Kubernetes service impact. So that's a great kind of starting point, Michael, in terms of the chillers not coming back online after the power sag event. And maybe the next question for you or for Albin, do we know why some of these chillers didn't come back online? Why those 13? And what did we do about it in terms of the manual intervention?
And Mike, all the question. So as what Michael alluded to earlier, there were 3 voltage sags caused, on that day itself. The first 2, the systems operated as per design. They rolled through. The third sag was slightly different in terms of the nominal voltage, and obviously from that perspective, the equipment reacted slightly differently. What's kind of unique when we look at the analysis of the condition where those 13 did not restart, they had to fit a certain criteria, right? Specifically, it all happened with one specific brand of equipment, and they had to be operating at close to full load. That means 2 compressors within the chillers had to be operating. So you have to have the 2 conditions whereby specific brand. Second condition is 2 of the compressors must be running. And in those situations, and in that situation and in that specific state, we have what we call a cooling management system that controls, cooling within the various data halls within this facility. As what Michael mentioned, this facility is fairly large. We have different cooling pods, and within the cooling pods, they're all controlled by a cooling management system that stages chillers up, stages chillers down based on load, as well as when there's a voltage sag, the CMS is supposed to stage up standby chillers to take up a load in case anything trips and all that. So that's all automated. The system should be designed and operate as intended. That means every time there's a voltage sag or interruption, the CMS would essentially be the smarts around activating standby units. So in this particular incident at night, there were 24 chillers that transitioned via various stages. Some went down, standby chillers came up through CMS intervention. 13 specifically did not start. And based on those 2 conditions that are outlined, when we did the analysis, there was really a mismatch in time and logic between the CMS and the chiller controller, resulting in the chillers requiring human intervention. That means the lockdown, it required the facility technicians to actually climb onto the rooftop where all the chillers are laid out and then go pod by pod, turning them on, one at a time. So, that's essentially what happened. Specifically for that 13, they were able to restart 8 of them. Unfortunately, the last 5 chillers that support these 2 specific data halls, they were at the far end. So from a technician perspective, they went through pod by pod. There were 4 groups of chiller pods that they had to manually recover. When they arrived at the last port, the last 4th port, essentially they ran out of time because by the time they reached the last port, the temperatures were way too warm, and it didn't allow the teams to execute the EOP to restore the cooling, and we had 5 chillers that essentially were not able to return to service, and that's the reason why there was a thermal runaway in these 2 specific data halls.
So, super, thanks. And I remember reading in the PIR, going through the PIR, one of the things that struck me is, as you said, you were restarting those chillers sequentially. And the way I imagine it in my head is, once upon a time, we had a campus, and over time, our footprint has grown, and so the campus has grown. And so initially, we had an EOP, or an emergency operating procedure, that says, hey, we start from A, we go B, C, D, E, F, G, and we go across. And my understanding is to say, look, the way it should have been done, it should have been done load-based, where you kind of go round robin and you slow down the cooling. Have I understood that correctly, or is there anything more to it? I mean, I'm very interested in this. And then really kind of another question is, what about our other data centers around the world? Are we always going to left or right on all of them? How are we looking at these?
So, I mean, that's a really interesting point, and this really, data center is like built differently. This data center is probably on a big plot of land. It's horizontally spread out. Well, in certain parts of Asia, we have data centers that are high-rise, 9 stories high. They have a central cooling plant. You don't really have to run across the roof, right? So in certain localities, it's just one location, one central plant on the ground floor. This specific location is horizontally laid out, from one end to the other end. It's about 350 meters, requiring, the C technicians to actually go from port to port. In terms of EOPs are designed to specifically allow individuals to restart the systems. As over the lifespan, as what Michael said, of this facility, 5 years, we have deployed substantial capacity. And obviously, in terms of prioritizing chiller recovery, there's something that we should have done in terms of load profiling, understanding the load profiling, which ports are higher in terms of load profiling, and obviously addressing and improving the site situational awareness, so that the technicians that respond at night or anytime during the day, they would know which port to go to in terms of addressing the situation. I mean, in retrospective, if the technician went to the ports that had the high load profiles, turn a couple of chillers on, that could have rolled through everything. But, in terms of the sequential nature, that's probably something that we, was a key learning for the team there.
That's great to hear. Thank you for running us through that, Alvin. I had a quick clarification here. I know, so for customers who aren't as familiar, we generally, for our big major incidents, there's kind of 2 different post-incident reviews. Within 72 hours of mitigation, we try to get a preliminary post-incident review out with, here's what we know so far. And then we follow that up, and within 14 days of mitigation, we publish our final post-incident review. So a question for you, maybe, Michael, is, I know initially in the preliminary PIR, we mentioned some comments around staff levels here and about how many people we had on site. I know that the preliminary PIR didn't really characterize that properly, and we actually had more people on site than we said we did. But if I understand the repair item correctly, it sounds like even though we temporarily added staff, to make sure that we were in a good spot after this incident, the real fix here isn't more people, encasing in a linear fashion. The real fix is that mode-based sequence in the EOP. So that doesn't change staffing levels. Have I understood that correctly?
Yeah, I think the 3, which came out in the report, that's just relates to people who are available to go and reset the chillers. There are obviously people in their operations staff on the site, and there are also people in the operations center. So that information was incorrect. But you're right. Again, I would just, if you can cast your mind back and imagine you're in the moment, right? So 20 chillers, right, post the 3 SAGs are all in an erroneous state, right? And some are in the process of getting auto reset, and then they're all getting an auto reset tried, but then 13 of them require a manual intervention. So immediately you have to deploy those resources across a very, very large site. And, just imagine you're there. So you got to run out, up onto the roof of the building, go and manually reset the chiller, right? And you're on the clock. So if you can imagine, everywhere your chillers have been impacted, your temperatures are rising. So they're scrambling across the site to try and get all of the chillers reset. They don't quite get to our pod in time, and then we have the thermal runaway. But the optimization that could have easily happened is, we need to go to the highest load data centers, the ones which have the highest thermal load or the highest amount of racks which are operating, and make sure we recover cooling in there. So it isn't recovered the 13 chillers, it's recovered the chillers that have the highest thermal load. So it's a tweak in how the EOP is deployed, but ultimately what the system is supposed to do, the software should have taken care of it. The chillers should have had, like, the auto restart should have happened, right? we shouldn't have needed to do a manual intervention. And that's the piece that we fixed, right? It isn't that you never want to deploy humans to fix problems if you can get software to do it for you, right? So that's the condition we fixed, right, by updating our chiller management system. So that logic has been updated, so it should never occur again. But in the unlikely event that there is some sort of a failure that requires a manual intervention in the future, the EOP then has to be updated that if you end up in a multiple chiller down situation, that you prioritize based on load within the data halls. And that is something we need to drill not only on this side, but we need to drill it across our global fleet.
Got it. That's great to hear. I'm glad that throwing more people at the problem isn't our solution here. So good to hear. I was reading the post-incident review and I understand that from 10:30 UTC we saw some automated hardware shutdowns. It was at 11:30 UTC where we started to manually shut things down to shed load. Now, when we announced this session, customers have the opportunity to pre-submit questions as part of their registration form. We had several questions from customers asking, how do we decide, which hardware, which services, which racks, which services, how do we decide what's selected for shutdown? Or are we at the point where we were just shutting down the entire kind of infrastructure within those data halls to try to shed that thermal load?
I can jump in on that one, Alvin, if you like. What basically happened in the hall was the hall got too hot and we had to turn off the power to it, just to preserve the electrical integrity of the equipment in the room, right? Had we left the situation ramp on further, there's a potential that we could have impacted things like SSDs or computer hardware. Alvin, anything you want to add on the back of that?
And Michael, we have dealt with multiple issues over the years, thermal, power issues. I mean, we do have a standard playbook. We move first-party workload softwares, and after that, compute and storage. And if there's a thermal issue, so we allow services to fail over. But in terms of this situation whereby there was a thermal runaway, and obviously the runaway was extremely quick, it made decision making much more crucial, and there was a lot of information that's being passed to the team. We didn't want to misrepresent or provide incorrect information or inaccurate information that could lead to different trains of thoughts in terms of decision making. So we wanted to be cautious right before we did anything in terms of shutting down load, because we know that when we shut down load, it's extremely painful in terms of.
So. And I do have a question. Now, when we go through the PIR again, the timeline is fantastic, and the timeline kind of understands the play-by-plays. One of the pieces that was interesting to me is from when we got our temperature stable in those two halls to when we started powering up hardware again was 1 hour and 40 minutes. Now, this struck me as an extended amount of time, 1 hour and 40 minutes where temperatures were fine, but we didn't power stuff up. What was the delay? We mentioned a safety check, but does it take 1 hour and 40 minutes to conduct a safety check?
Michael, I can take this. I think it's important to understand, there's obviously coordination that's required between the facility team and the IT technicians that are, validating the equipment. Obviously, other than the safety walkthrough that has to be done, we had to power up equipment in phases, and obviously we do that to ensure that there's no surges, there's no additional trips that happen at rack level. And after that, once we power up, every row, the technicians will then go in and validate every rack by rack, to ensure all devices, all equipment is up, and it's healthy, right? So obviously, if you go through that sequence, it obviously takes a fair bit of time to ensure that you power it up gracefully, as well as ensuring that all equipment with the rack is up as well.
That's great. And then the last question that I had specifically around data centers here, again, one of these questions that we had lots of customers submit, people asking about a power cooling issue that we had in the Singapore region in Southeast Asia back from February. And we had a lot of customers asking, in what ways was this similar or dissimilar to that Southeast Asia incident in February? Are there any kind of points that we can compare for that?
Michael, I can answer this as well. I mean, I think the commonality is in both incidents is the all-use chillers. There's a cooling incident. There was thermal runaway, and it's all initiated in terms of there was a voltage sag, essentially a power interruption at the site level, and as well as, it occurred after business hours. I think that those are essentially the commonalities. I think in this specific incident in Sydney, most of the schedulers are actually auto-recovered based on design. There was a small subset, as what we mentioned, that required some form of manual intervention due to the automation, didn't work as intended. This represented, as what Michael mentioned, 3% of the impacted capacity in this availability zone. The difference in terms of the failure and the root causes in Sydney, it's a CMS logic and timing issue versus the one in Singapore, where it is a compressor control card which ceased after the power dip, which eventually inhibited the list from restarting successfully. I think in terms of the sags, it's all sags as well, but 1 sag versus 3 sags. But I think that it may look the same, but in terms of the underlying logic and the technology is actually slightly different.
Super. Thank you very much, both of you. Thank you very much. So it's interesting to understand, okay, we had the issue, we got things back up, and now we're getting to a stage where we can start powering up equipment. And as we powered up equipment, Tom, I'll turn to you. It was really interesting for storage. So what my read of it was customers who were using zone redundant storage were unimpacted. Customers using geo redundant storage were unimpacted. The only impact to storage was locally redundant storage, which is the just customers who are not kind of clicking any resiliency options. Now, predominantly this came online just shortly after we got the temperatures cool again. We started powering up racks, and at 3:25, we started coming back online. But there's a little bit more to the story with a little bit of complications. Could you walk us through it, please?
Sure, yeah. So we had around 1,000 nodes affected in the storage outage across 7 scale units. Most of it came back up very cleanly after power was restored. There were a few scale units, though, where we needed some manual intervention to bring things back, and there were a couple of reasons for that. We have multiple layers of safety check in the system to ensure data integrity and system integrity. And on certain hardware, there are differences in obviously the storage hardware we use right in different clusters. And in this case, what happened was one of the lower level safeguards in the system had decided that these scale units did not shut down cleanly, and it was blocking us from restarting the storage roles on those nodes, even though the storage level software safeguards, all worked as designed, and the system, we'd actually, kind of stopped writing data cleanly before we lost power or connectivity to the nodes. So there was some time to understand the situation and understand that we had a kind of a disagreement between different levels of safeguard about was it safe to allow storage to restart or not. So this was some time to kind of figure that out, and then we had to go through and reset some state on those scale units to allow them to proceed and restart the storage software layer.
Great, thank you for running us through it, Tom. So I had a look in the post-incident review that the only learning from a storage perspective talks about these kind of optimizations to the way that we recover from large-scale events like this. You mentioned a couple of them in there about data and TSGs. Could you just kind of talk us through what kinds of repairs those look like and how we think what investments we're making that for big events like this, whether it's caused by power or anything else, how we'll be in a better position?
Yeah, there are a few things. One was the just sort of TSGs. We haven't encountered this kind of situation before where we've had this class of hardware have this type of failure. So one repair is making sure we have a clear TSG for people to follow when we have a sort of thermal related outage, so we can more quickly identify what the problem is. The second issue we ran into was unrelated to the sort of specific outage. It was to do with the performance of tooling for going and changing state on several hundred nodes. We ran into some performance problems with that tooling at scale, which we're making sure we're addressing. And the third piece is we want to remove some steps from the recovery. So in this case, we had to go change some state across those affected 3 scale units. We then had to restart all of those nodes, which means they had to go through the boot process again and the storage layer startup again. So we're also taking steps to remove the need to do that node restart in this scenario in future. But those are the main improvements that we're making.
Thank you very much, Tom. Kinok, I'd love to turn my attention to you. But when I think about Cosmos DB, I hear and I read about a globally distributed database. And so when I think about in one region, in one zone, we had an issue, but why would this impact a globally distributed database such as Cosmos DB?
That's a good question. So Cosmos DB is globally distributed planet-scale database. Not every application is ready to become globally distributed planet-scale application. And while many of them do, and those that do, meaning they use active-active multi-region write capability in Cosmos DB, they largely did not notice and were transparently traffic was moved to it, all the writes were moved to the region, into another region. Some applications are not architected, not originally written in this active-active way. And for those applications, we offer two modes. One is availability zones. That's one method of protection. And second is we offer multi-region deployment configuration with single region write. And so applications were configured with Cosmos DB configured with availability zones did not have any impact. Applications that did not have availability zones or active-active multi-region writes, those were the ones that impacted. If they had a second region, they were eligible to and configured to be to allow us to fail over. They were eligible to fail over, and we failed them over. 95% of them were failed over in 35 minutes. We want to get better. And then those that did not have a region, a second region to fail over to, those had to wait until we recover.
Great. That's a good overview from the Cosmos DB perspective. You mentioned a little bit about why some customers aren't using these multi-zone, multi-region features. Could you talk us through the obviously cost implications, but in terms of the complexity to the application or data consistency, why that might not make sense for some customers or some workloads?
Absolutely. Generally, availability zones should make sense to everyone. Yes, there is a little bit of change in pricing, but it's pretty small. And it's worse. And generally customers should always, and usually after these events, we have a spike of customers enabling availability zones. But largely we hope that customers enable availability zones before. Active-active application does need to take into account active-active configuration. And so, for example, the application must be aware of the fact that we'll make a decision on there will be conflicts, multiple writes, two writes going to the same record in two regions, and we will make a decision if customers so chose to resolve conflicts. Last write will win, so some other policy, whichever policy was configured. Not every application is ready. Customers want consistency, after consistency choice, but it's not available. Or otherwise, just need to have an assumption that there are no conflicts. There is only single write at any given time. And for those applications, that's where the failover comes in. Always a good idea to enable service managed failover. Of course, you give us the right to decide when to invoke. And if you had a lower than strong consistency, obviously that may involve that some of the writes will be left pending and had to be resolved later. But it's a good idea to have this because those customers that we had, 95% of them were failed over within 35 minutes.
So on that, so 95% of customers were failed over in 35 minutes, but it was 5 hours from the impact start. Is there an SLA for when we're planning to fail customers over so they can know, oh, if I have this service managed failover issue, there's a timeline, and is there a criteria?
I mean, generally use this timeline a little bit first, just to kind of make it a little bit more crisper. The initial impact, until the power down event occurred, the initial impact was very small, and so it did not warrant the failover. Once the power down occurred, we, due to operational TSG error, we lost 30 minutes. And it's sad, but it's it was a silly mistake. The TSG, the service operation manual, the TSGs were configured to use a certain telemetry system that was also down because of power down event. And there was no, the TSG did not include the backup instructions of use the other telemetry system. And so we couldn't determine whether our control plane was up to perform the failover for these accounts. And there is also belief that the control plane was not configured to be zone resilient, even though it turned out to be false. It was perfectly zone resilient, perfectly available, but just on the side of caution, we performed the first 30 minutes, we performed the failover of the control plane with few additional steps, and that was not needed. So we lost half an hour. The project generally our SLO is we want to get our goal is to do these failovers for everybody within 5 minutes. Clearly, we're not there. It's 35 minutes was a significant improvement, let's say, from the Southeast Asia incident back in February, but nothing to be so proud of, be celebrative about. We can and want to fail over everyone within 5 minutes. That's our goal, and we're pretty making certain improvements to make it reality.
Ajay, thank you very much, Kirill. Asad, if I could turn my attention to you. Before we cover the impact and there was a long recovery for SQL, could you help us explain, could you help us understand the SQL architecture and how it's designed?
Yeah, absolutely. And some of the things are definitely common between like how we run the databases. So we obviously have a ring that is created of compute nodes. And then on top of that, we run a distributed compute platform, which is called Service Fabric. And then on top of that, we run SQL as an application, stateful application. So again, like as the chillers went offline and the power went offline, obviously all of the tenant rings within that availability zone were down, and that is where the initial impact started. And then as the power came back on, most of our tenant ring came online. Actually, all of them came online as expected. Within one of the tenant rings, there were 20 nodes which continued to be down, which was like the compute did not come up with the Service Fabric, and as a result, the SQL was unable to start on those 20 nodes.
Got it. So, Asa, if you would help us to understand, it sounds like there's kind of two different types of impact here. There were people who were zonally resilient, and most of them were unimpacted, but there's an asterisk there. So I'd love to understand, what that small tail of people who were designed to be zonally resilient, but it didn't quite happen. And then can you contrast that with people who weren't zonally resilient and kind of what this would have felt like to them?
Yeah, no, that's a great question. So first thing is covered by some of my other colleagues as well. People who are zone redundant, they did not have the impact. Because in that case, if you are deploying your database, the replicas are deployed across the availability zones. So when one zone goes down, your database is continued to be accessible and fully operational. The subset which you're talking about is that we use the gateway to redirect the connections. Anybody who was using direct connection to their databases had no impact if they were zone redundant. A small set of databases that went through the gateway proxy, they had an impact. And then that is again one of the repair items which we had fixed earlier and pushed that update to most of the regions, but this region had not gotten that update, which was like all the gateway connectivity gateways should also be zone redundant, and that fix is in now. So that was the small subset, but generally speaking, all customers who were zone redundant, and that's a choice customer make. And again, that is something which we are trying to push and educate more, which is that is the right way to deploy. And in SQL, like if you are using your business critical SKU, then it comes at no cost. So there is no reason not to do it. If you're using a general purpose, since it has a single compute node, that one comes with some price increase or price impact. But generally, availability zone is the way to go for resiliency.
Super. Asad, for customers who aren't using it, and SQL have an option for the auto failover trigger. And I'm interested to understand, because one of the repair items was an amendment to this. Is this done manually today? Is it the SQL service that decides how is this trigger executed?
Yeah, no, good question. So today, so basically, when we think about the resiliency within the data center, the resiliency is obviously distributed across the availability zone. Now, think of it is that if you want to do a full DR, which is like everything is down and I want to make sure I can fail over into a different region. That is where the DR story comes in, and hopefully not new for people coming from the database background. And we have, what we do is that when you set up the DR, and I will call out like very small percentage of customer had DR in there, whether manual DR or auto DR, very, very small percentage. So when they had to set up the DR, they can always go and manually do the failover. That option existed, and they can go to the portal even when the primary is down. They can do a forced failover into a different region. We also look at ourselves, and if you have enabled the auto DR, we say if there is a regional outage, we will do the auto DR for you. And that is something which comes with lots of little of the ifs and buts, which is like if the region is down and the primary is down, what is the data loss risk they have? What are the signals we should look at in terms of the severity of the outage? How long is the outage? And all of those things are important because think about it, when you fail over a database from one region to another region, it's not just about your database. Like what you have the entire stack built on that. What about you are using Events Hub, you are using your application layer and all of that. So typically it is the customer makes the choice, but we do have the option where we do it auto. And that is where, as you called out, we could do more in terms of understanding customers' setup beforehand rather than when the disaster happens. And that is one of the repair items we are working on in terms of how we can make auto DR more efficient. So that even if the customer does not take an action, and they can take the action anytime, but if they don't take the action, how we can take the action on behalf of those customers.
So, and just to clarify that, so my understanding is as customers are doing this, they're able to specify under what conditions that failover would occur?
Today, those sort of rich options do not exist. Okay. So basically, either they can always go in the portal and they can do it on their own. But if they are relying on us, we need to enrich that input ahead of time so that we make the right choice for the customer.
Great. That's a good overview of kind of the different ways that this kind of SQL impacted customers. So with that, I'll turn our attention to Chi. I know we have Chi online, who's our VP of AKS. Now, Chi, I know just as we've talked about for Cosmos and for SQL, Azure Kubernetes Server seems to have struggled here. So my first question for you, is it right to think that AKS wasn't built with the zonal resiliency in mind initially?
Okay, that's right. AKS wasn't built with AC in mind because AKS was built back in 2017. When we started, the zone was not a concept. Even AWS introduced the zone in like 2019. Right. So at the beginning, this is when Australia East and the Southeast were one of the early regions we created. We checked the time they were created. They were created back in 2017. At that time, there's no zone redundancy. Of course, later when zone redundancy was introduced, AKS was, we changed a lot of our infrastructures and the deployments to make sure that our own binaries are run in a zone redundant way. For instance, AKS itself, Azure Kubernetes Service itself, is running on Kubernetes. So our pod is distributed among different zones to make sure that if one zone is dead, the rest of the pod, the workload can still handle the incoming traffic. What was missed in this one is AKS still has a lot of dependencies. One of the dependency of Azure Kubernetes Service is a SQL Server. We use that SQL Server for a bunch of queue operations. And in this case, for Australia East, we didn't turn on the zone redundancy after the zone redundancy was introduced into that region. So this is a big mistake, of course. We missed that. Even though our new infrastructure paving code, like the build out all has zone redundancy enabled, but because this was old, we failed to audit all of our infrastructure. So this is the lesson we learned, that afterwards, we should periodically audit all our infrastructures, all our dependencies, to make sure that wherever zone redundancy is available, we should enable that.
Fantastic. I have a follow-up question as well. But the AKS was the only service that had multi-region impact in this case. And you spoke before about how, okay, we had the SQL DB that was built in a zone before zones were available. But this was this same SQL DB that was in one zone, was it also responsible for the workloads of multiple regions?
That's a very good question. So also at the beginning of AKS, there was no zone. So we were thinking, hey, we don't want to lose the data in case a whole zone, a whole region was wiped out. We cannot afford to lose all the data for our customers. So we did this sector DB, which is a region-to-region replication. So we did a cross-region replication with pair regions. So we pair every 2 regions together. So Australia East and Australia Southeast were the 2 regions paired together. But then later on, we realized that if we have all the infrastructures, let's say VMs, service load, standard load balancers, and every infrastructure construct a Kubernetes service is all regional, what's the point to have the data replicated if we could just back up? So we changed the direction. We have split all those sector DBs, the paired DBs, into regional, and adopted the SQL backup strategy to avoid loss of data. However, again, we are at the almost at the end of converting all of these paired DBs into single. We are switching because this database is just used for queues. We are switching to use the service bus, and we're switching to use the zone redundant service bus per region. And we are in the process of switching when this outage hit us.
Super. Thank you very much. Thank you, G. Great. So those are our kind of specific questions that we're directing to the individual services that were impacted. I've got a few questions here that I want to kind of throw up into everyone. I haven't tried this before with 3 people here in Redmond and 3 people live online, so we'll see how our AV team keeps up. And internally, we do lots of drills, right? I'm constantly hearing and reading about all the different types of drills and disaster recovery drills and zone down drills and power drills. What are we learning? What are we learning from our internal drills that we are kind of putting into practice here? Any specific service responses? Yeah, cool.
Yeah, I think the one important learning that we've had is that when we do these drills, a lot of the situations we create are very clean, very synthetic. Okay, everything is powered down. We never do, this and then a little bit more and then a little bit more, a little bit later. Also, surprisingly, our telemetry systems are always up during those drills, which is probably not the greatest idea. So there's lots of learnings around the mixing it up and creating more chaos-driven drills as opposed to kind of planned synthetic drills for outages. That's my... The other part is that you see more and more services adopting, and kind of Cosmos DB, for example, is going to bring in a few months this capability to customers, allowing customers to simulate these chaos situations, including outages. For example, one replica goes down, what happens if 2 replicas go down? So they can test how their application behaves during these drills, beyond the SLOs of service providers. So even when you're active, if you had some specific logic in your application, what happens when the redirected traffic to another region? Does that leak extra latency across region? Does it impact you? Is your application spinning over correctly? So all these you will be able to test. That's another learning for us that we're going to invest more and more in allowing our customers to simulate together with us.
Super.
I have another question as well. Just to add to that, I was going to say, I agree very strongly. The gray failure is the thing, right? The drill versus the reality, where you get these creeping and flapping failures, right? The second thing I think is interesting about this failure is that it's environmental, and thermal issues particularly, it's less predictable, right? When you have a whole different mix of sets of types of hardware, ages of hardware, you can have some different failure modes that are very hard to simulate in a drill. So I think that's something we might need to think about a bit more. It's a hard problem.
Well, I'm hearing that our drill team should throw more curveballs in there as well and just shut down more telemetry and so on. I know that we endeavor to get these PIRs out very quickly so our customers can understand things, but I don't think our learning and understanding of the incident just stops once we publish the PIR. Have there been any learning since we published the PIR? Had, given more time, we could have shared other snippets of information, or did we kind of capture everything in the right time frame and ship it out, and now we're done?
I think the one on the SQL side definitely is, I would say that customer wants more power in terms of like when some things like that happen, where like they want a button which like empower them to get out of the region or things like that. And we are working on those type of the features, because like I think like the notion with the past is like, okay, you have the SLA, I don't have to go and worry. But like when the incident like this happens and they're on the support call for, let's say, 5 hours, 6 hours, 7 hours, at that time, it's not about like what Microsoft can do, like it's also about what they can do for themselves. And it does come back to what also Kirill said, that if they do these drills on their own, for those drills to be successful and effective, like it's like, okay, I have the control on myself as well. Like obviously I expect Microsoft to do the right thing for me and deliver the SLA. But when the worst happened, like what can I do on my own, right? So that I have not fully given my business and my destiny to a company. Obviously, I expect the best out of them. But when a thing like that happens, what can I do? So I think that was something which is a very valid thing. We, especially on the database side, like we are looking into like how we can empower them again. And DR is one great example in terms of what you can do on the portal itself through the APIs and others. To take care of things on your own.
Yeah, that's a great point, Asad. And that's kind of one of the common themes that we're hearing as we go through all of this. Tom talked a lot about customer resilience and choosing the right storage redundancy options. Kirill talked about customers making sure that you're in a multi-region where you need to be kind of bigger than that. Same thing for SQL, for AKS, that we're, as much as we know that Microsoft needs to learn and improve from these incidents, and we do, a lot of our customers, first-party internal services as well as third-party customers, are really reliant, or when they realize they're reliant on some of these resilient technologies. So my question to the panel is, are we seeing more customers taking advantage of these kinds of resilience technologies, whether that be multi-zone or multi-regions? I mean, you mentioned we see an uptick after incidents like this, but are people getting the message that, putting all your eggs in one basket brings these risks?
For storage, we're definitely seeing significant uptick in external customers, including some very large customers in terms of volume of data opting for ZRS. There's a lot of demand. Internal as well, it's been a journey for Microsoft, right, for the first-party services as zones become available more widely. Definitely been a journey to get the different first-party services and moving over to use zone redundant storage, but we're seeing significant increase in uptake.
Great, good. Anyone else want to add anything to that? Cheese got a hand up. I love Teams. Thank you.
Yes. So for AKS users, we have seen this as a common ask. And also the best practice we advise to customers is definitely leverage zones if the region has them, and leverage as many as you can. Usually it's like 1, 2, 3, or some regions with 5, so that you can distribute the workload among different zones. And Kubernetes, the nice part is, especially AKS, we have the zone supported as a label on the node, so customer can easily use the node selector and the anti-infinity rules to help them distribute their pods among the nodes between different zones. So this way, when one zone get impacted, their other zones will continue to serve the traffic. Another thing is to split your control plane away from your data plane. For instance, in this incident outage, it's bad that AKS control plane was completely down for Australia East, but actually the data plane was running fine. And if customer had used a cluster autoscaler, they wouldn't even experience. Of course, you still cannot call the RP to create new clusters. That is bad. Totally agree. But if your running clusters could stay intact, and it can self-scale up and down based on your workload, it can continue to achieve that elasticity during this outage. So yeah, so we one advice or the practice is to put all these leverage the zone redundancy features, and also help to split the control plane, data plane separately. That can definitely improve the resilience of the service.
That's great. Thank you, Jim. Really appreciate that. So I'm mindful of time here, but I always save the last question for my fellow co-host here. Sammy runs our communications team. So here we are communicating with customers. I want to understand during this incident, how did we do? Were we able to keep customers updated? What improvements do we have from a comms perspective?
For comms, there are a few things. So first of all, Brain, which is our automated comm system, fired, and it fired quite well for a lot of services before we shut down the infrastructure in the halls. The great side was that storage would fire, compute would fire, SQL would fire. The downside was that this meant there were 50 tracking IDs, 50 separate incidents. We don't do a good job today correlating these incidents together and kind of looping them together as one. In terms of the time, of course, Brain started communicating as impact was happening around the 10:40 time. At 11:30, when we shut down hardware, we had already had a communication up on our status page, and we had also notified all customers within the region, hey, there's impact, and this is what's going on. Now, the pieces where we're in, some of the good news as well is that we were able to offer ETAs. Typically, we want to be kind of sure, and for the 95, 99% of the recovery, we were bang on. We said in 2 to 3 hours we should be recovered. I think for the most part we were there. We found it tricky to offer ETAs for the tail end of the recovery, partially because it was complicated, as said, and as Tom have alluded to. It got very tricky for that tail end, and we couldn't really offer an ETA. But for the 95 and the 99%, we managed to offer an ETA so customers were able to understand what was going on. The last piece which we really want to make investments in is when we communicate a zone outage, unfortunately today we communicate to the region. And we were getting to a place where we're able to communicate not only to impacted zones, but even impacted data centers. And today we're very loud and we're very noisy. And it's also very difficult for customers to understand if a zone is impacted, is it the zone they're in? We know the logical to physical mapping can be confusing for customers as well. So it's something that we've got to go and get better at. But moving forward, our roadmap does look like we'll be able to commute more granularly at a zonal level and at a data center level as well. So of course, comms is never perfect, but some of the commitments that we've tried to make earlier, particularly around ETAs, particularly around communicating quickly, we're not perfect, but we're making steps in the right direction.
It's great to hear. So just as our various service teams have their own repair items and initiatives, comms still getting better, still got room for improvement here. So I'm mindful of time, but thank you very much to everyone on our panel for joining us. Thank you to folks dialing in online, and thank you to all of our customers and partners joining into the session. We hope this has been an interesting conversation about not just failure, but about learnings and how we're constantly improving.
But one of the key reasons we do this is to ensure that when customers migrate their workloads to the cloud, it's not a black box and people understand what's going on. We know that service events or outages are inevitable, but listening to the conversation today, it doesn't mean that impact has to be.
Right. Yeah. And then just as we've been talking about customer resilience throughout this, I always end with a couple of calls to action. The Azure well-architected framework has a lot of our best practices and guidance around how customers and partners can harden your own services to expect these kinds of problems. I mean, we were talking here about, not just the individual resilience options per service, but also technologies like Azure Chaos Studio that let you kind of go and inject faults from the library and break your app on purpose to see how it responds. So another kind of great call to action around customers taking accountability for your own resilience to these kinds of problems that are unacceptable and yet somehow expected at the scale we operate at.
And one of the baby easy steps that everyone can do is to please set up the service health alerts. It keeps customers informed during the outage. They can get an email, an SMS, a text. They can plug it into their problem management system with the webhook. And more importantly, if you want to be invited to these retrospectives and these live streams following major outages, those service health alerts are a great way to get an invite.
Great. Well, these sessions continue to push us in the directions of being more accountable, being more transparent. We hope that you find our new kind of upgraded post-incident reviews more detailed than before, and that these sessions help to improve trust. So thank you again for joining us. We hope you found the conversation insightful, and thanks to all of our team here.
Thank you.
Cheers. Thanks.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.